So that brings what we can describe as functions of the soil food web. So now we understand there is this soil food web. It's made up of these animals, but what do they do? What are their functions? So organisms and soil biota are in the greater numbers than those in agricultural soils. So when we create what we might call designer soils, we increase the numbers of these things, okay? So we want to work on the soil food web to increase the total population. Thus, they increase the diversity and the functional interconnectedness. So the more that we work with this, the more diversity, the more connectedness, and the more increases. Plant diversity directly affects the soil food web diversity. So if you're doing like a monoculture and you're only cycling this one nutrient back through one plant, right? That's not going to be as diverse for the populations as if we had a diverse food source. And that's why we went to try to find a diversity of things that we put into our compost. They like a diversity of foods, just like we do. We don't want to eat the same thing every day, every day, every day, every day. It's not very diverse. So we want to try to understand the role of each of these components in the web. And we're going to see how they play, and they can then allow us to observe problems in our garden. So then when we see a problem in our garden, so when we get into the end today, we're going to be looking at how we can identify the nutrient deficiencies by looking at a plant. So if I look at this plant, and I have lots of these, right guys? Every day I could put a new one, right? Brand new, beautiful, but I don't. Good, no problem. I don't even have to have Jason do it. I could just ask Khio. It would be magic, right? But that plant has a nutrient deficiency. So at the end of this class, we want to see if we can identify, just by sight, what's wrong. And then if we were to add that to it, give it that what it's telling me it wants, it would recover. This is what we tried to do this for. Why do we want to be able to do this? So I can learn and I can communicate with my garden. My garden can talk to me, but it just doesn't talk in vibrations. Okay, so this is the thing. It has communication. It's more like nonverbal communication. So mycorrhizals, okay, as the first organ of nutrient uptake, the mycorrhizal network imitates nutrient cycling. So this controls all the nutrient cycling. That's the big boy. As a medium of soil structure, it controls the structure and binds the soil together with the mycorrhizal networks. It determines the flow of water, nutrients, and air, directs the pathways of root growth, and opens channels for the movement of soil animals, the little animals. So this is the thing that's basically controlling the entire soil structures. In other words, the mycorrhizal network is practically synonymous with ecosystem function. So one of the first steps we can do is find out how to inoculate our soils with more mycorrhizal networks. So this means that I showed you guys how to do compost the Berkeley 18-day style, just like everyone does. But do you notice that there's not a lot of piles? Did y'all kind of figure that one out? There were like a lot of those piles? Could make one every day if I wanted, right? Because that's really basic. And we want to make better soils. We want to make more designer soils. So we want to see how we can put mycorrhizal networks into our soils. We want to work on the water-soluble aspect of biofertilization with anaerobic and aerobic conditions. So in the soil, it's aerobic and anaerobic at the same time. So if we only focus on the most base level, the most basic of composting, and nothing else, well, you'll do okay, because if you put more than 5% organic matter, you're going to do all right. But you may not have the nutrient retention, right, that you desire. And so your plants might not be as, say, healthy for you as if you had worked on a little bit more of understanding how the nutrients are moved in the first place. So some benefits of working with mycorrhizal networks include nutrient uptake. So it increases the nutrient uptake. It increases the plant growth. So you can do trials where you can see an increased plant growth. The drought resistancy because of water retention. I don't need to use as much water. Disease resistance. My plants don't have as much fungal or bacterial diseases that we may see. The plants are healthier. A reduction in weed populations. Weeds don't like healthy soils. So if we understand their condition, we can reduce them. They don't really like that type of soil. And we can have an improvement in the soil aggregation, which is the structure of the soil, which improves all of those things. So there's like this inverse relationship. The better you fix this, the better it gets. It's like a faster thing. So you could call that exponential. So our site will not have mycorrhizal fungal networks if any of the following has occurred. Earthworks or tillage have taken place. This is particularly if I dug a pond, obviously I disturbed them, right? But in a pond instance, I'm not trying to grow mycorrhizal networks in my pond. I'm using that to provide water. So, but if I'm in my broad scale landscape and we plow and we turn over the soil and we let it oxidize, we let sun and oxidation, those networks will be broken. If we cut them, we cut it. Because guys, this is an animal. This is not a plant. It functions and it has the characteristics in all fashions of an animal. And the only way that you'll describe it as not is because you say, well, no, it's a vegetable. It doesn't move. It's all teeth. Hell, think about it, when it decides that it wants to propagate, when it wants to procreate, how does it do that? The little phallic symbol comes out with the exact same proportions as most other mammals, and then it puts forth spore. Come on. So this is what we need to understand. What is it doing? And if we go in and cut it in half, do you think it likes it? No. So we can kill it. So we don't want to plow and destroy our mycorrhizal networks. So that's why that concept of no-till, agriculture, and even there's a French, even the most high level, I think, personally. I watched a lady on YouTube and she just was like, wow. She calls what's synergistic farming. Synergistic farming says you don't touch the soil ever, and she won't even pull the weeds up. So what she does is she takes a scissors, and she just sticks the scissors like right below the root and cuts them. So 80% die because they got cut right at the root, and she leaves the roots and the roots die, and then the mycorrhizal networks and everything eat the roots of the weeds. So it's like, and then she takes the top and she just lays it right on top. She doesn't take it out. So nothing comes out of her garden. Everything that was grown in it goes just laid as mulch. Yeah. Well, you start to play with the balance. Those places that they're doing that are so degraded that you don't have mycorrhizal networks. That's why there's nothing growing. So when you go and you see the freaking like first level grasses, there's so much compaction that nothing's really going on. So at that point, that's why they describe it as a kind of almost a restoration agriculture. We have to go in and do restoration practices to get the soil to grow back. And we have to appreciate why that happened, because that happened through some type of typically human activity or management decision. So the human management decision created that, compaction or loss of life due to synthetic chemicals or whatever. Okay. So soil erosion is a problem. If we see soil erosion, that's probably a sign that there's something else happened and the soils are defoliated. So foliated soils, really good strong soils, don't erode. The site has experienced a fire, maybe a forest fire came in. It had such extreme temperatures that it actually can kill even the bacteria, okay? And it takes time for them to recover. Extreme weather conditions, that could be flooding. So maybe it flooded and it was 2 weeks that it was underwater. Could kill them. They're flooded for too long. Or it may be possibly a freeze of too long. And in synthetic chemicals, typically what we see in agriculture, the plowing and the use of synthetic chemicals has been used on plants, and especially fungicides. If you spray fungicides on your plants, probably that's a relationship to them being sick because they have reduced soil conditions. And then when it rains or waters, that goes in, kills and it gets worse, and then you wonder why your plants never get better, and you keep spraying the thing that kills so some kind of poor relationship. So what are these mycorrhizals? Well, how can we add them to our site if we don't already have them? So yeah, interesting, we could grow mushrooms, but if I don't and I can't grow mushrooms, it's not a problem. You can inoculate plants with already inoculated soils. So as I discussed when we were doing our compost, if I don't have a compost pile and I want to try to get a mycorrhizal compost going, then I would go to the edge of a forest or a tree, right, underneath a large mature tree, side of the road with trees that have been there for 20 years. And I go get me some of that really great, what we might call forest canopy, like the topsoil. And if I take that, it's going to be inoculated with that. And then I'll bring them and put them into my compost pile to inoculate my compost pile to get mycorrhizal networks. So the mycorrhizals will be living there, but they really haven't formed a network yet because they're all, and we flip it, so they're there. But when we get them into our beds, they can stabilize, and then that's how they can build these networks to move nutrients, okay? So that's what we want to do. So that brings us to the concept of nitrogen fixing and carbon sequestering. So how do I fix nitrogen and I sequester carbon? So nitrogen is an essential macronutrient needed for plant growth. It's probably the most important. It's for size, guys. So the bigger, if you want big plants, you need high nitrogen, okay? So nitrogen is size. Nitrogen fixers take nitrates from the air through an exchange of nitrogen for sugars from soil organisms. So that's the photosynthesis creating the sugars, and they're fixing the nitrogen to exchange it with the bacteria for the minerals. This creates a small node on the roots, the little white nodules, which is our usable nitrogen source. So when the nitrogen, or if we're practicing chop and drop techniques in our food forest, and we pollard, which means to cut, if I want to pollard something, so imagine a tree here, and if I put a big P and I go, cut me at the head, right? The P would cut me, that's pollarding. That means I cut right at the, and then I'll grow back my arms, right? So it cut me. But if I coppice something, it's a big C, cut me at the feet. So at the base, I coppice something at the base, the C cuts, and pollarding is at the top, and I cut here and my arms grow back, right? Different. So those two things will stop the photosynthesis because the leaves are taken away. The relationship, the bacteria will die, the plant will take up the nitrogen to grow more leaves. So that's the relationship that we use for legumes to fix nitrogen in a chop and drop regime. We'll talk about that in more detail in the food forest section. So carbon sequestering is the process of capturing carbon dioxide. So I have to understand there's carbon dioxide in the atmosphere and how the carbon dioxide is captured to sequester it into soils. We can do that and increase the carbon capture on our farms through cover cropping. So that would be like, for instance, after you grew your main yielding crop, say if I did want to grow corn, after I grew corn, then I would plant sun hemp. And sun hemp is a nitrogen fixating flower. And so it's pretty. It grows relatively quickly. 30 days, you can cut it for what's called green manure. So we would cut it down, and then we would feed that plant functionally to the next plant. So that's what we call cover cropping. Or rotational grazing. I could grow a crop again, say sun hemp, and then I would allow goats, sheep, cows to go in and cut that crop with their mouths functionally and poo back onto the field where they were eating. And then that would bring the source of what we call green manures back in, so that the next plant that I might do, so after I rotationally graze that, I might then come in and plant pumpkins, right? So then I grew this plant to feed this plant, okay? And regeneration of degraded land. So any of these techniques we might approach if we see, as permaculturalists, degraded properties, that their agricultural techniques have degraded the property through mismanagement, and then therefore the value of their property is now considered low. We could say, hey, well, look with my improved management techniques, right? And biological systems, I would be able to regenerate that property into a more productive standpoint. And then guess what? The value of the property is tied to its productivity. So we're going to take a little break there, but we're going to come back and we're going to look at the 6 steps of understanding the soil food web. So we're going to roll through these steps, and this will give you that really good understanding what's going on. Then we're going to shift gears and talk more about nutritional standpoint of remineralization and moving our minerals, getting our minerals into our soil. So tomorrow when we make our biofertilization, so that we can add minerals to our biofert to get to our plants, we'll understand why.